Bismillahirrahmanirrahim. Hi, Assalamualaikum. I am Brother Muhammad Amil bin Muhammad Yusof. We are from Group 3. We are going to present about the project that we do, which is about hydropower plant. So before we look into the design or the way we construct this power plant, we need to look into the context of why we did it. Uh, it is because there is an isolated village which has a very poor access to electricity. The village has a small population, around 5 families, with an average 3% per family. So they need electricity for the lights and the basic house appliance. So approximately, the village need about 90 kilowatt hour per day to fulfill their need. So we are going to develop a hydropower plant there. And the village also has a waterfall with a high water flow. So it is strategic for our hydropower plant.
Warahmatullahi wabarakatuh. My name is Fakrezi bin Abdul Samad. Number metric 2115585. Okay, today I want to talk about CDIO, which is the part 1 and 2, which is concept and design. Okay, first of all, I want to talk about brainstorm hydropower plant. Okay, the first thing is I want to talk about problem, which is we found that this some environment impact, cost, maintenance, and bad infrastructure area. Okay. For the classification of our plan is we want to use micro hydropower plant because micro hydropower is useful for small villages that we want to select. Okay. Next, we also want to use run of river system, and we want to use supply turbine. Okay. The functions of our plant is we want to produce electricity to the small village, and we want to produce electricity by using renewable source of energy, which is waterfall and flexible. Okay, for the material that we choose for the hydropower plant is aluminium because it is lightweight and corrosion resistant, and the material must have high density polyethylene because this uh, item is durable and resistant to corrosion and low frictional load. Okay, the next is we want to use concrete because as we know that concrete is resistant to water pressure and have strength and durability. Okay. For the red ocean and blue ocean, we want to use for the blue ocean, we want to use automatic and remote monitoring because it's easy for us to monitor the situation at the power plant without going physically to that place. Okay. After that, we also want to use fish-friendly turbine system because it will save and save the environment and not damage the environment. Okay. For the trimming and scamper, for the trimming process, we we want to we plan to reduce the water reservoir size because it will save the cost and minimize the environmental damage. Okay, for the sample, we want to use the smart material like piezoelectric materials because piezoelectric may transform the vibration at the waterfall to becomes the useful power, which is electric power. So it will give more increase the efficiency of our projects. Okay. Next, we also want to add some noise reductions, like we want to put some foam composite panels, or we plan to put some sound absorbing material that effectively dampen noise vibration. Okay, for the random entry, we want to reduce the habitat damage, so we want to fish friendly turbine. I say that we want to protect the fish and environment, and we want to maintaining minimal river flow. Okay. We also want to implementing fish ladders or fish bypass system because it will prevent fish from getting harmed. So the fish will not go near the turbine. Okay, for the design, I want we for the turbine design, we choose the Kaplan turbine because it can perform well even at low heads, which are typical in run-off river installations, and can operate effectively over a wide range of flow rates. This is the 2D sketch of the Kaplan turbine. Okay, this is the Kaplan turbine 3D designed in computer-aided drawing. Okay, as you can see in the picture, this is how the water flow into the Kaplan turbine and generate electricity. Okay, this is the run-off river system. Run-off river hydropower plants harness the kinetic energy carried by water by using the natural downhill flow of rivers and micro turbine generators. The turbine that we have chosen, which is the Kaplan turbine, will be used in this hydropower plant system. So we choose the run-off river system because it will help us more. It will make our project more efficiency. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rafiq bin Muhammad Jamal. My matrix number 117645. So now I would like to go through with my part, which is implement one of the element of CDIO for doing some project. Okay. Now I will explain about the implement. So my team have considered a certain things, and that's one of the thing. First thing is budget. So for our project, which is a hydropower plant system at Waterfall, so I have decided 6 factors according to the budget. So the first factor is site assessment and feasibility study. Okay, this one is includes conducting survey, hydrological studies. Hydrological studies means that study of amount and quality of water being stored on the land surface and environmental assessment. Okay, next factor is civil works and infrastructure. This one is include all of this description is important to the hydropower plant system, which is water division structure, intake, and store, powerhouse, and access roads. And the price is 230,000, around 250,000. Okay. The third factor of the budget that we consider is turbine and generator, which is important thing also in hydro plant system. The cost of turbine generator will depend on the power capacity. So power capacity depends on area that we decide to build some hydropower plant at there. So if we decide to do at small area, so the cost will decrease. The next factor, which is electrical system and controls. This includes the electrical component like transformers, switchgear, wiring, control system, and monitoring equipment. And the price is around 46,000. So the fifth factor is environmental mitigation. What's the meaning of environmental mitigation? Which is the project that we do is also to prevent any environmental effect and any environmental impact. So we must we can do the project, but not to destroy the habitat of the habitat lifestyle of the animal, plant. That one also to be considered to build some hydropower plant system in the at the waterfall area. So the lastly is permitting and legal fees. So this is one permit, license, and legal assistance can incur the cost also. Okay, so I continue with the second element that our group decide in this hydropower plant system project, which is testing. So for the first thing, we measure the electrical system in our hydropower plant. So electrical system is to ensure the accurate installation of the hydropower and also the performance of each of the component in the hydropower system. So we apply the power equation and also Ohm's law and also power loss equation. So for the second test, we apply also turbine performance testing. So as we know, hydropower plant is very related to the turbine because turbine is one of the major component in the hydropower system. So in testing, we uh, we measure also the performance of the turbine. So we to know their efficiency, the power production, and the speed of the turbine in the hydropower system. So we apply the turbine efficiency equation. We apply also hydraulic power and lastly power coefficient. Next, we take also the testing measure of the generator in the hydropower. So why we test the generator? Because to get the voltage control, the stability of frequency, and the power factor. So we apply generator efficiency and power factor equation at here. Last but not least, we measure the water flow by using this equation. So why we measure the water flow? Because to get the water flow rate that enter the system. So by doing it, uh, we can know system is functioning within the predicted flow range and that the turbine is getting the necessary water flow. Okay, that's all.
Now I am going to talk about operate. So from the aspect of operation management and a hydropower station need an evacuation plan. The management of a hydropower plant need to prepare regardless of the crisis specific. People need to be able to leave the hydropower station when there's an emergency. So the next thing is training and operation. The first point is control risk management. So the management of the hydropower plant need to provide training for the worker, so they are prepared if there is an emergency or hazard happening at the power station. So planning ahead to avoid workplace accident, illness or injury is a general strategy to prevent the injuries or accident from happening. So the management need to ensure the work system, the equipment is well maintained by the worker, so there's no accident happen. The next point is safety application. There's a turbine speed control and brake system monitoring. It is essential to maintain the stability and the efficiency of the turbine. The brake system is important if there is a heavy rain or increase drastically of the water current flow. It is important to slow down the turbine to make sure the turbine is still in a safe condition. The next thing is the water level measurement system. So water level, flood, and evacuation alarm are essential for the safe operation of hydropower plant. Any failure in the level measurement system, it will cause a big problem because it will endanger the crew and the environment around the hydropower plant.
Okay, so I would like to continue this presentation with the vibration data for the project. Okay, this is as you can see in the slide, this is the coding for spectrum 1, spectrum 2, spectrum 3, spectrum 4. Okay, I use the MATLAB to complete this coding, and this is the graph plotted for each spectrum. This is graph number 1, graph spectrum 2, graph spectrum 3, and graph spectrum 4. And as you can see, this is the coding for time 1, time 2, time 3, and time 4. And this is the graph plotted for each time. Time 1, time 2, time 3, and time 4. Okay, from the graph, we can identify some data and we can do analysis. Okay, for the spectrum analysis, it can help us to identify some dominant frequencies, while time domain analysis, it allows us for the evaluation of the dynamic response over time. This information will guide us to the design and implementation of effective measures to limit flow vibration. As you know that high levels of vibration can result in failures, loose bolts, loud noise, and fractures. Okay, high vibrations also may lead to some health concerns, including fatigue, headache, and digestive disorder. So it will make the villagers unhealthy if the vibration is higher. So we want to limit the flow vibration using this data. Okay, to this is some prevention efforts that we found. Okay, we need to routine examine the and servicing rotating machinery to guarantee appropriate balancing and alignment. We will use some precision alignment methods and dynamic balancing of spinning pieces can be used to accomplish this. Okay, we also want to install vibration monitoring system that will assist in identifying excessive vibrations and if specified criteria are exceeded, alarm or shutdown can be triggered. So we will notice if some excessive vibrations are identified. Okay, for example, to lower vibration amplitude, we will put some active control device like vibration dampers or absorbers. Okay, that's all from me.
For part C, it is very simple. You just need to enter all the variables that is needed here, and it will automatically calculate the total head friction, available energy, available head, power, and the power efficiency. Here, you can see the table for the water level. This table will be automatically generated when you just enter all these variables. And it will also plotted the graph for the decrease of the water level for 10 years. So the next thing is the option of how we want to improve the power efficiency of the hydropower plant. We can improve the piping system from the reservoir to the turbine by using pipe with a smooth internal surface for less friction. And then we can increase the available head to increase the maximum output of the power from the hydropower plant.
So I will continue to the last part, which is part D, that the question asks to provide hazard identification and countermeasure to ensure the safety of your team during the task to investigate the flow rate, the water flow rate, and potential hit for the hydro system. So from this picture below, I have found 6 hazard identification and also its countermeasures for it. So the first hazard is just using the rocks for the workers to cross from one place to another place. As you can see, there's the rock, there's no bridge for the workers to cross to another place to do some work or maintenance. So the countermeasure for it is to build strong walkways or footbridges across the nearby area of all the waterfall. These structures should be created with proper handrails or guardrails for increased safety, be able to withstand the flow of water and offer firm footing. Next, for the second hazard is more scattered wire near the water area. This area. So this is possibility for the workers to get electrical shock because of it. So the countermeasure is the wire should be adequately supported and secured. So the ways to do are by using strong poles, support structures, or cable management system at the scattered wire. So after that, we move to the third hazard, which is there is no mark or cover for the electrical devices and potential power sources. You can see number 3 is near the cave. As you can see, the power source may be inside to the cave, and there is no mark or big mark assigned for the electrical location. So the countermeasure is to notify people that there are wires nearby and to prevent access to the dangerous zone, create large warning signs and barricades all around the area. So people should be told to keep their distance from the potential hazards by the signs, which should make this clear. For the fourth hazard is the base is unstable and not strong enough for support heavy objects. As you can see, this is a heavy object. There's a few heavy object, and the base was not too unstable and not too strong. Based on this picture, they just made the base from wood surrounding. So they make it base not strong enough. So to countermeasure it, increase the base strength by adding more support structures to it. So to improve stability and load bearing capability, this can involve setting up more beams, columns, or bracing. Next, hazard is do not have any technology or device for lifting heavy items to a desired location. So from this picture, we can see the workers may have difficult to lifting the heavy things like this its own tenant. So for lifting from one place to another location. So this will make this will affect the workers back pain ergonomic factor to the workers. So to countermeasure, build temporary structures such as ramps, pulley systems, or improvised hoists using available materials in the surrounding. This structure can provide mechanical advantage and aid in lifting heavy items. And finally, available land is limited and unsuitable for use as the main location for a hydropower system. Yes, this is true that the location for this area was limited and unsuitable and unsafety also for doing this hydropower at this area. So to counter measure for it is consider a hydropower system that uses run of river and doesn't require a large dam or reservoir. It still make use of the available water resources while reducing the amount of land required for construction.